I was going through the release notes for the latest Arduino IDE, that's Integrated Development Environment, version 2.3.2, when I noticed something new, the addition of a live debugger. So I wanted to check that out. If you're unfamiliar with in-circuit debuggers for microcontrollers, check out YouTuber Andreas Spiess version number 274. The link is in the notes. The first half of that video describes the advantages of the in-circuit debugging technique. The second half describes a specific implementation, which I tried but never got working very well. It could have been my fault. I was using an old PC and an old version of Windows, and the download was very slow, and it would occasionally crash. So I kept my eye out over the years for debugging methods available within the Arduino ecosystem. And this version looks like something I want to check out, and that's what I do in this video. Just a note, the demo doesn't use any Arduino hardware, and I think that's how they make their money. So please consider a donation to Arduino when you download the IDE. Thank you. And now on to the demonstration. Okay, this is our test setup. On the left is the ESP32-S3, and on the right is the Raspberry Pi Pico W. So we have two different CPUs, two different compilers and build chains, and we will be debugging the two processors at the same time. The Arduino IDE will be taking care of all that complexity. The Raspberry Pi Pico requires another product from the Raspberry Pi Foundation called the Pico probe to provide the debugging interface. That's this up here. The Pico probe is $12 US, and the hookup instructions are provided with the product. An option when buying the Pico board itself is to get one with the Pico probe headers already installed. Otherwise, you have to solder in a 3-pin header to the Pico board. The ESP32-S3 has a built-in debugger and requires no external circuitry. There are two USB connectors. Use the connector shown here. Okay, let's start up the Arduino IDE. Okay, we'll start with the Raspberry Pi Pico W first. First thing we do is check the Arduino IDE version number. And it has to be at least 2.3.2 for the in-circuit debugging to work. Okay, I'll go through these pretty quickly, and you could stop the video at any time to verify. So the Pico W is the board, and okay, so I'm using a Mac, so it uses a Unix path name, whereas Windows will use a COM port. Like this would be COM port 12 or something. But in Unix, so on a Mac and Raspberry Pi, you get a path, a Unix path type. Board information, it's a RP2040. This is wrong, but it has to be just close, and it shouldn't error out. Okay, so let's go tools. We should check every one of these tools options to make sure it's correct. Debug level all, debug port disabled. We're using on the Raspberry Pi W, Pico W, we're using the external Pico probe, so this should be disabled. So let's go through all these here. Bluetooth stack, we're going to be using Bluetooth. We're going to be using the Raspberry Pi Pico as the central, and the ESP32 as the peripheral, and the ESP32 will be using I2C to connect to all the different sensors and actuators with Bluetooth LE. Debug optimization is the enemy of debugging. We want all the debug information. Let's go on. The Pico probe is what we have hooked up. It's the protocol is the CMSIS-DAP Pico SDK, and we're done. So let's go through the typical Arduino steps, and we'll do verify first. Done compiling, we'll be doing upload. So it's connected, and to the USB connections are correct, and this JTAG scan lines are being exercised now. And we're done uploading. So the first thing we're going to do is set a breakpoint here. On the Raspberry Pi Pico, it goes through, the usual setup and loop on the Arduinos. So it goes through the setup quickly and then immediately jumps to the loop. On the ESP32-S3, it goes through setup and then stops at this brace. But the Raspberry Pi Pico just slams right through and starts running the loops. So we'll set a breakpoint there. So we've downloaded. So let's start the debugger. Bam, we hit the first breakpoint. Okay, so I put a loop counter in here and I added it to the watch window. So let's let it run again and should increment. And it's at 2 now. So it just turns a light, LED, the small LED in the upper right of the display. They're blinking lights. So let's let it run free. And it's blinking away. So let's start up the ESP32-S3. Open recent. Here's a blink RGB S3. Okay, let's check a few things. It's got the correct dev module. And now we need to go through and check everything. ESP32-S3, it's on this Linux or Unix path 22201. Yours will probably say a COM port here. Board information, let's do the board information, see what it comes up with. It's not quite correct, but at least it didn't error out. That's a good thing. So let's go through the tools again. We'll go through these and you can stop if you're interested in any of them. The debug level is debug. Run on core 1, on and on and on. We're using the integrated USB JTAG on the ESP32-S3. Core 1, on and on. No PSRAM, on and on. And the USB mode is hardware CDC and JTAG. Okay, so I think we're set on the S3. So let's go through the Arduino steps again with verify first. Compiling, this is Extensa compiling. And we're done compiling. Let's set the breakpoint anyway. I think it's going to stop, but let's set a breakpoint right there. And so we haven't uploaded yet, so let's do that. Compiling sketch. Okay, now we're uploading. Done uploading, so let's hit the start debugging. Okay, so it stopped here. This is different from the Pico. It stopped very politely at the end of setup and didn't blast through to the loop. So we have to set, let's go ahead and hit play. And now we hit that first breakpoint, loop counter. Let's run to see that the loop counter increments. So let's hit the play again. Okay, there's a warning. Okay, we hit it that time. I don't know what that was all about, but it seems to be working now. The loop counter's at 1. And let's stop the display when it's on red. So we'll set a breakpoint here, and we'll let it run. And it hits the breakpoint, and then the LED's on red. Let's stop it when it's on blue. So let's let it run. And we stopped on blue. That's great. So It says Cortex registers, which is correct for the Raspberry Pi Pico, but this is Extensa architecture, so I think that's mislabeled. And the Cortex peripherals, we're going to use this as a Bluetooth LE peripheral, and we're going to use I2C for the sensors and actuators. And this would be useful. I think there's some I2C registers here we can look at, and there's all kinds of stuff here, which would be interesting if you knew about I2C setup. So I think that's all we wanted to show, so let's let this run on the ESP32-S3, so we should have both processors running. So let's go back to the Pico and hit a breakpoint, and let's check the loop counter. It's at 269, so it's been running all this time. So let's let that run now. So now we have both processors up and running. So that was a demonstration of in-circuit debugging, live debugging, on both the ESP32-S3 and the Raspberry Pi Pico W using the Arduino 2.3.2 version. Okay, well, thanks for watching.